Okay, well, we found a way to compute determinants, and in this section we're going to find alternative ways of computing determinants, which can be much easier. All right, now remember when we computed the determinant up here, the way you did it was you took entries, here let me erase some of this junk if I can, okay. You took entries and then took determinant of the remaining submatrix. For instance, the first term was this number times the determinant of this row, this submatrix. Then from there, the second term was minus the second entry, then take the determinant of this 2 by 2 submatrix. And the third entry was take this one and take the determinant of the submatrix. Now notice there was an alternating in signs, plus, minus, plus. Okay, so when I use the first row to compute the determinant, then I have this plus, minus, plus pattern. And it's good. And if there were more columns, I would just keep going plus, minus, plus, minus, plus, minus, and so on. Okay, now we used the first row in this case. It turns out that you can use other rows as well. The only difference is that if you start with the second row, for instance, if you expand on the second row, instead of going plus, minus, you have to go minus, plus, minus, plus. If I'd use the third row, I'd go plus, minus, plus, minus. If I use the fourth row, I go minus, plus, minus, plus. So if I expand on odd rows, I go plus, minus, plus, minus. If I expand on even rows, it's minus, plus, minus, plus. Okay, that's reflected in this first formula here. If I use the ith row, then the coefficient of my first term is multiplied by minus 1 to the I plus 1. So think about it. If I is equal to 1, I'm going to have minus 1 to the 2, which gives me 1. If I is equal to 2, I don't know why it's doing that. If I is equal to 2, then I have minus 1 to the 2 plus 1, which would be a 3. Okay, so we have alternate ways of computing determinant, not just using the first row, but other rows as well. And we'll see examples of that in the future. Now another thing that is helpful, that I'm not going to prove, but is a fact, the determinant of the transpose is the same as the determinant of the matrix. And there's a proof here that that works. And what that tells you is that instead of using rows, I could use columns. So instead of using the first row, plus, minus, I could use the first column, plus, minus. Okay, so again, there's a long proof of that. But let's do some examples. I think that's the way to really understand how to do this, how to deal with these things. Okay? All right, so here's one determinant. Let's compute this determinant based on the fourth row. Now remember, since it's the fourth row and that's an even row, I have to start with a minus. So that's where this minus comes from. I have to start with a minus. Then I multiply 4 times the determinant of this submatrix. Okay, so that's where the 4 comes from. And then this submatrix is where this submatrix comes from. Okay, so that's the first term. Now we have 4 columns, so there's actually going to be 4 terms. The second term is going to feed off of this. Now remember, the first term was a minus, the second term is going to be a plus. So that's what this is. If you work out minus 1 to the 6th, if you have minus 1 to the even power, that's a plus number, that's a plus 1. Okay, now I'm going to multiply that by the constant, and then I'm going to get my submatrix by crossing out this row and this column. And you can see that the remaining submatrix is exactly what I have here. So that's the second term. Okay, so first term was minus, second term was plus. Let's go on to the third term. Third term starts here. Cross out this column, this row, this column. This one's going to have a minus. 2 times the remaining submatrix. You can see this submatrix agrees with this one. Okay, and finally, for the last one, go to 6. I'm going to have this element goes here. This is minus, plus. This is going to be a plus. So that's where this comes from. And then I'm going to take the determinant of this matrix, this submatrix here. Okay, so when you're doing these problems, follow along with these examples. and do the computation the same way. All right, so that's one way I could possibly do the computation. Another way, as I said, I can use columns instead of rows. So I'm going to use the third column. Okay, now that's an odd column, so it's going to start with a plus. Remember, if I start with 1, I have a plus. If I start with 2, it's a minus. If I start with a 3, it's a plus. Okay, so what's good about expanding around the third column? Well, look at these zeros. They're going to help me quite a bit, because if I take my first term, it's going to be 0 times stuff. Now, as soon as I get the 0, I don't even have to worry about computing anything else, because I'm going to have 0 times stuff, and that's just going to give me 0. Okay, so that's neat, so I don't need to compute anymore. Then consider this one here. All right, this 0, again, I have 0 times stuff. I don't care about the stuff. It's all going to turn out to be 0 anyway. Okay, so all I have to do is, I have to do this one. Now, is this a plus or a minus? Remember, because we start, since it's the third column, we start with a plus. So it's plus, minus, plus. This is going to be a plus. That's reflected in this here. Minus 1 to the 3 plus 3. Where is he getting this 3 plus 3? That's the third row, third column. That's what he's doing. He's starting with third row, third column. Okay, so we have the minus 2, which is here. Then we have the submatrix. We cross this out and cross this out, and you take the remaining matrix. That's what's right here. Okay, sorry, that cross out shouldn't be so aggressive. Okay, so we have this minus 2 from here. We have the minus 1 to the 3 plus 3, because this is the third row, third column. And then we have this submatrix here. Okay, let's do the last one here. This 2 here, this is going to be 2. And then this minus 1 to the fourth row, third column. That's how you can get the sign of the term, is take the number of the row plus the number of the column. And then the remaining submatrix is this matrix minus 2, 3, 1, 9, minus 2, 1, 1, 3, minus 1, which is the matrix here. Okay, so we found different ways of computing this submatrix. Okay, this is particularly useful when you have something like this, like a triangular upper matrix. Okay, so what I can do here, by our upper triangular matrix, I can expand on the first column. Okay, let me expand on the first column. All right, the first entry is going to give me 2, and then I cross out the row and the column. That's going to give me the determinant of this submatrix. And I have minus 1 to the 1 plus 1, because I started with the first row, first column. Now, what happens with all the other terms? Well, when I go to the second term here, I'm going to have a 0 times stuff. I don't even care about the stuff. That term's going to be 0. Same with all the rest of them. I should have 4 other terms, but they all turn out to be 0. So after I finish the first column expansion, I only have one term. 2 times minus 1 to the 1 plus 1 times this determinant of this submatrix. All right, so let's work on this submatrix here. Let me expand on the first column here. So I have minus 1. Okay, and this minus 1 is also in the first row, first column, so I have minus 1 to the 1 plus 1. Then I'm going to take the determinant of this submatrix here, and that's what's down here. And then similarly, all of the other terms in the expansion, when I take this, and this, that's all going to contribute 0. Okay, so I actually end up with one term. Okay, so let's go on to the next one. Same deal. It's kind of getting repetitive. I'm going to take this one times the determinant of this submatrix, and this is 1 plus 1 again. So it's minus 1 to the 1 plus 1. And then I know the determinant of this. What I actually end up with is the product of the diagonal entries. And that's true in general. No matter what upper triangular matrix you have, you can find the determinant by taking the diagonal of the upper triangular entries. Okay. All right, there's the definition. Minor is the determinant of the submatrix. Cofactor is include the minus 1 sign. Okay, so those two definitions may be used. You might see those in other books. All right, so we'll stop there.